Hello,
Sounds good.
everyone. Good afternoon, good morning, good evening from wherever you're joining us from. My name is Dalia, and I work as a community manager here at Kong. I'm very happy to welcome you to our last Tech Talk for 2023. The topic for today is Gateway API. Very interesting topic. We're going to learn from Shane. I will let him introduce himself about the history, about what's coming up, basically everything you need to know. And we're going to take all of the questions at the end. You will see there is a Q&A function on the bottom here, so please insert all of your questions there. This webinar is recorded, so the recording will be available in about an hour on our YouTube channel, and I will put the link in the chat. So with that, Shane, please take it away.
Sounds good. So yeah, Gateway API, we're going to talk about what's next after general availability, version 1, which released just a little while ago at KubeCon. For those of you who have seen Gateway API before, you'd be interested to know that little logo there, which just looks like the Kubernetes one, is the one we came up with for our Gateway API official logo. So that's the new logo. I'm Shane Utt. I am a staff software engineer here at Kong. I focus on networking and Kubernetes. I'm also one of the 3 Gateway API maintainers and a chair of SIG Network. So I help out with like coordinating and doing leadership stuff for SIG Network and upstream Kubernetes. Our agenda for today is, well, the audience is probably going to be, we expect a lot of people who already know what Gateway API is, but certainly some that don't. So we have a brief introduction to Gateway API for anybody who hasn't is coming in just kind of like, what is Gateway API? But then the main focus will be to talk about Gateway API's origins, key decisions, the road to GA, which was the critical months leading up to the GA release, and then ultimately beyond GA, what are we doing next in Gateway API? So this talk is like for anyone really that is interested at any level in Gateway API, but you may particularly be interested if you want to contribute to Gateway API, because we're going to talk about the process of like building the API over the last 4 years. And then it also may be particularly interesting to anybody else who's like maintaining large open source projects or are trying to get to the point where their open source project is large, because there's like some learning, some retrospective. We'll talk a little bit about things we learned doing what ended up being a huge project that we didn't realize would get as big as it was. So we'll start with that brief intro and a little bit of probably just a recap for others, but what is Gateway API? So it is the next generation of Kubernetes routing and load balancing APIs, intended to kind of go to the next generation of like the ingress API and service API. Right now, today, it's heavily focused on layer 7. We have HTTPRoute, which is kind of the main API in which people interact with. But we're experimenting with other use cases like L4. We have a TCPRoute and UDPRoute API, which are in alpha. It's designed to be expressive and extensible, and it has a role-oriented resource model. Expressive and extensible. Basically, our goal with expressiveness and extensibility kind of came from what we learned doing ingress over several years. So that is the ingress API within Kubernetes, which you hopefully are familiar with. If you're not, you can find that on the website, but it's been the longest running kind of ingress API solution. So basically in the ingress days, we learned that like there was a portability problem. Extensibility was done mainly through annotations. So this ended up making it so that any particular ingress resource that somebody was maintaining would not really end up being portable to almost any other implementation, because the annotations would be specific to that implementation, and it just was all of the configuration was done in a special way specific to that implementation. So expressivity and extensibility kind of are wrapped up in a goal of portability, and we'll talk more about that in the upcoming slides. As for being role-oriented, ingress was like one API. You may have had your implementation provide some other APIs which could influence it or do policy and stuff like that, but ultimately it was ingress. Now we have things like gateway class. Gateway class is something that an infrastructure provider will provide. It may literally just be a gateway class is a very simple resource that often enough just has a name in it, which says what controller or operator is responsible for gateways. The infrastructure provider, the person kind of deploying your cluster, might just put that in there and say, okay, Kong is the gateway class. You can use Kong for gateways. And then the cluster operator would use gateways, and they would connect these to the gateway class and say, I have a gateway. I want to use the Kong gateway class. It would, in the case of like the Kong gateway operator or Kuma and Kong mesh, create a gateway and manage the configuration and lifecycle of that gateway. That's for the cluster operator. And then ultimately, and this goes back more to like what ingress looked like, Then we have the application developer role, and they just make an HTTP route and point it to one of these gateways. And we'll talk more about this as we go. Digging in a little bit. So gateway classes, usually there's not a whole lot to it, but gateways, it's kind of what you'd expect. There's a gateway class name. In this case, it's just Kong. So Kong's responsible for deploying and managing the lifecycle of this gateway. Then there's listeners. So like this has a HTTPS listener with a host name that it matches and TLS configuration. There's also in the status things like the IP address for the gateway. So this describes how traffic can be translated to the service within the cluster, and it can be a load balancer or a proxy. And in our case, it's often a proxy. So HTTP routes, they are kind of the best analog to the traditional ingress resource. They enable HTTP and HTTPS traffic from outside your cluster to the services within your cluster. They have a parent ref field, which you can see here, which points back to our gateway from the previous example. And that is to say that gateway is responsible for this route. We have host names and rules to basically match traffic and send them to the right backends. Backend refs can select those backends, and by default is a Kubernetes service, but it's open-ended. You could use anything. You could use your own custom CRD at your company if that's something that you had. And we have a bunch of different features in HTTPRoute on top of ingress, like we've been able to expand because of this difference in specification. For instance, in this, you can see that we have weighted traffic splitting. You could have a weight of 10 on the first backend ref and a weight of 90 on the second to do a canary rollout and like slowly roll out an update. So those features include, but are not limited to, TLS configuration, HTTP matching. We can do host, path, header, method, query param, cross namespace, gateway, and route binding, which is something Ingress didn't really handle and your implementation might have, but it was really up to it. That's actually kind of an official part of the API now. Cross namespace forwarding, HTTP filters with header modifiers, request mirroring, request redirects, URL rewrites, and then you saw the weight-based traffic splitting. This is kind of just scratching the surface. There's so many more in progress, and we've had so many possibilities for extension that there's already things in the pipeline, and we'll talk more about that. So that was a brief introduction to Gateway API. Hopefully that clicked and made sense for anybody who is new to Gateway API. If not, please do check out this our website. This is our page, What is the Gateway API? Should kind of be a breadcrumb to lead you to all the other pieces to learn about Gateway API. So we talked about what is Gateway API. Maybe just as important, probably more important, who is Gateway API? So this is a massive project in upstream Kubernetes. 170 plus contributors have contributed to this repository. This is just a sample of them, and it keeps growing. We have new contributors practically every day, if not every week, certainly. And it's a very popular upstream project, which we didn't necessarily anticipate, and we'll talk a little bit about that in this talk. And that's 30 plus organizations that are kind of represented behind a lot of those contributors. This is just a sample of the top 10 in terms of the actual number of commits by specific contributors in these orgs. But that keeps growing. So the interest level from organizations is enormous, not necessarily expected either. And just thank you to everybody who works with me on Gateway API with us, because it is what it is because we have such a booming community around the project. So we'll talk about how we got here. How did Gateway API get here? This timeline, which if you saw our talk from KubeCon Chicago, this is like taken directly from that because I think this is going to end up actually kind of being the timeline we put on our website. It's kind of the official timeline to tell people about the history of the project. But 2019 was the beginning. Brainstorming sessions started there in KubeCon San Diego. 2020 is when we kind of started getting things a little more figured out. We had a V1 Alpha 1. We were trying to figure out the shape of things. 2022 is when we did some refinement and the shape started to really take form with V1 Alpha 2. 2022 is when things hardened, stabilized, and we started doing V1 Beta 1. We also started talking about how to do Gateway API for mesh using Gateway API resources for mesh. I'll dig into that a little deeper in upcoming slides. 2023 is now, and we are V1. Layer 7 ingress support specifically is V1 GA ready to go, stable for the future. Mesh support had graduated to experimental, and again, we'll talk a little bit more about mesh. Digging into the timeline a little further. So 2019, 4 years ago at KubeCon San Diego, It was basically just we wanted to talk about the next generation for ingress and service type load balancer specifically. That has changed slash not necessarily come to full fruition. The ingress part has, but the service type is still something that we're actively working on. But the generic goals, like the high level goals of being generic, expressive, extensive, extensible, and rule oriented, these haven't really changed over the years. These are the same goals today. We just have potentially more goals, which we'll talk about. In that same time, the language and like the thought model was a little different. Like you saw earlier, gateway class, gateway route. We had infrastructure, router, backends was kind of like the high level thing, and then we specifically broke it down into like gateway class and gateway were there very early on. But we originally were doing like virtual host, and virtual host could point at a service or your own thing or another virtual host potentially. Um, and that was kind of inspired, I think, a little bit by like Istio was doing stuff like this at the time. That ended up moving to routes. And at that same time, we knew that one of the biggest problems was portability. So we started talking about, we came up with this concept of support levels. In ingress, you would end up with every implementation doing these annotations that were entirely unique to themselves and not portable at all. And if they were somewhat portable, the implementation behind it might be significantly different. So it might have like some nuances in how you'd express it. What we came up with was the idea that we'd have a core API where everything is 100% portable. Basically, every implementation can and must implement the core API. If they cannot, so if some implementations can't, instead of them just doing something wildly different from everyone else, we still make that a part of the API with the extended layer. So it's portable if it's supported. And ultimately, we have custom. We usually refer to this now as implementation specific. But the idea is that these are things that we're like with extended, we can do conformance tests and have like at least the implementations that can do it run those tests. With implementation specific, that's like things that we can't really test, but we know they exist. So we try to provide some level of awareness of them in the API to help with the portability problem. And the idea is, and this stands till today, we are still using this model. Gravity just kind of naturally brings these inward as we pull people into the community and as part of the project, things will move towards the core API over time. Not everything will, but some things will. And this was our answer to how to handle portability overall. So we jumped from 2019, like the early infancy, to 2020 and V1 Alpha 1 and getting this figured out. It's basically all questions during this time. What's the scope of the API? What are the roles we want to support? How do we translate this into resources? What belongs in each resource? How do the resources connect? Who's going to implement this? And then how do we even release a CRD-based API? That's an interesting one that could almost, it has in fact had talks unto itself, but basically we are an upstream Kubernetes project, but we're not in tree. And that was an explicit decision in hopes of basically being able to kind of iterate quickly. So we chose CRDs, and we were the first upstream project in Kubernetes that has done this. So we're breaking ground for other projects and stuff like that. It's been interesting. We'll talk a little bit more about it. But we had to figure that part out. We came up with the resource model, which is that is very similar to what we have today. You have your gateway class, which is basically the infrastructure provider, which will have parameters. And there's a field in gateway class called parameters, which is optional to kind of add parameters to the gateway class. There's gateways for the cluster operator, routes for the application developer. And at this time, we had added TCP and UDPRoute. And we were kind of thinking about all the different types of routes that we might attach to gateways. We also did the hardest thing in software development, which is naming it. We just did it by voting. So Gateway ended up winning, but I think you might find it interesting to know that Router ended up getting second place. It was really close, all things considered. And interestingly enough, fast forward 4 years later, the router thing kind of, there's groups, especially like telcos and stuff like that, that are getting involved with Gateway API now that literally want a gateway to be a router rather than a proxy, if you will. So the use cases keep kind of growing, and the language, unfortunately or not, we're on gateway, which is unfortunately an overloaded term, but that's what it's going to be for now. So V1 Alpha 2 is kind of when everything just started, the rubber really started hitting the road. So the project finally started to get early feedback. We have implementations that are actually ready and implementing the API at this point. And actually during this time, at Kong, we added gateway API support to both Kuma Kong Mesh and our Kubernetes ingress controller, often called KIC. And then we started work during this year on our Kong Gateway operator, which was a new operator for Kong Gateway in the operator sense of like Kubernetes operators for the management of configuration and lifecycle of Kong gateways in Kubernetes, built kind of as Gateway API first. So Gateway API was like the initial API that is used, and that actually recently released. GEPs were introduced, and that is the Gateway Enhancement Proposals. And it was basically a lean version of the upstream Kubernetes enhancement proposals. Let's talk a little bit more about how GEPs play a role in our development over the years. Gateway route binding was all refactored. Like basically, Gateway got a huge refactor for this release. Reference policy was created. This has been renamed, but this is how we solved that ingress problem I talked about, where like in ingress, you couldn't really express that you didn't want an ingress resource from one namespace reaching a service in another namespace. That could potentially be a not good thing. So we have reference policy. It's actually reference grant now, basically for granting that access. And then we renamed the project from Service APIs to Gateway API. Service APIs was the SEO for that, like trying to search that was insane. Gateway API is better. It's not perfect. So yeah, and then policy attachment was introduced. We'll talk more about that in upcoming slides as well, but basically this deals with trying to attach policies to routes, timeout policies, stuff like that. So getting close to, getting into 2021 and kind of the heat of it, this is the model you saw at the beginning. We have been kind of stable or going with this model. Nothing's changed significantly at the high level for a couple of years now. Gateway classes, gateways, and routes. Policy attachment. So policy attachment has been an interesting one because policy attachment these aren't specific Kubernetes APIs like timeout policy and health check policy and retry policy that we provide yet. We don't know if we will actually. Instead, it's a reference implementation for people to do these things on their implementations. And the reason why it got into that state, and it is in that state today, is largely because we found that a lot of these things aren't super portable. So we decided to go with a direction of at least trying to provide guidance to, if it can't be super portable, at least the APIs can follow the same guidance and be kind of similar between implementations. That would be better for the users. Ultimately, fast forward a bit, and I'll talk about this in some upcoming slides as well, but the thinking about this has shifted a little bit, and it will, at least now in experimental, we are looking at adding a potential like upstream policy called backend TLS policy for handling the basically when you'd have HTTPS to the gateway, and then the gateway would have a different cert for talking to the backend. So that's still an ongoing thing, and that's not part of GA specifically, but it's something that's kind of being actively developed. So yeah, V1 beta 1 in 2022, all this stuff starts hardening. We move the three resources that are kind of being implemented the most to beta. Conformance tests begin, and I can't possibly stress enough the importance of conformance tests. We'll talk a little bit more about that. Gamma, the gateway API for mesh management and administration starts. So that's actually a sub-project of the sub-project. So that is a group of people working specifically on service mesh, and we're kind of trying to figure out how to use gateway API resources, specifically HTTPRoute right now, in a service mesh context. Reference policy got renamed to reference grant, moved to beta. Interestingly enough, the impact and the helpfulness of a reference grant, of being able to say this thing in this namespace can use this thing in another namespace is allowed to use my service, that ends up being more generally usable and helpful. So we're actually looking at that particular one, making it into entry as something that would do more than just networking things. You'd be able to use it for HTTP routes, but you'd also be able to potentially use it for any number of things that would need that kind of delineation. So that is an ongoing thread in upstream Kubernetes to make that, change it, and actually put an implementation of that in Kubernetes itself. gRPC route got to the experimental channel at this time, and I would say it's probably the most mature route other than HTTP route at this time in terms of the number of implementations implementing it and tests for it. One more year ahead, we're in 2022. service mesh, Gamma starts really picking up steam. Basically, SMI group, which was an upstream or an open source project to kind of like do service mesh, more or less shifted into doing Gamma instead. Some of the people from that group shifted to Gamma. And then we made the beta announcement where we said, okay, yeah, we're doing service mesh. Routing for Gamma is very similar. We have yet to have to make a real, like an actual specification change to HTTPRoute. That's how well it's been aligned so far. You just use a service at the moment. This is experimental, so we're not sure that's how it's going to end up in the long run. But today in the experimental channel, you do a service as the parent ref rather than a gateway. And there's a couple of implementations, including Kuma and Kong Mesh, which implement this at the moment at a preview level, and you can actually go try that. One of the biggest, so conformance, or sorry, support levels is one of the most important things we did that helped with our portability. Release channels, which is different, is one of the best things we did for our ability to iterate and move quickly, despite being an upstream project, which those tend to move slowly. So we added, or basically we split from going from like a config of like everything in a release just goes into one config. We have two separate channels. One is standard, that's stable. That's where things that we are like conformance tested, they're ready to go, they're stable, we're guaranteeing backwards compatibility for them goes. But now we also have the experimental channel, and that is, you could think of it as like beta, alpha. It's basically things that are not for sure going to make it into the API. This can just be fields on existing APIs that aren't in stable, but they are in experimental. And they give you kind of like, they give us the ability to iterate quickly and ship experimental features while we're shipping standard in the same release. So both of these channels will be represented as different like customized configs that you can deploy depending on which channel you want to subscribe to. And this has given us an incredible amount of flexibility. It's been a really good thing for the project. 2023, here we are today. It's been 4 years into it, 26 implementations of the API. And that was actually kind of before it went GA. So we'll see what happens after GA. Service mesh is now actually considered experimental. It was in like a proposed state before. Gateway class UDPRoute, they are GA stable. We are going to protect backwards compatibility for those resources. Other routes are not yet. We added the ingress to gateway project. And so that is actually like an ops tool for taking an existing implementation where you're using ingress and converting it automatically over to gateway API. And what's interesting is it helps with the portability story, because we leave it, it's an upstream project, but we leave it open to the implementations. Like before, every implementation might be doing something wildly different. We have it open so that implementations can come in and build their conversion logic into this project if it is convertible to Gateway API. So basically, implementations are asked to come put their conversion logic in there so that those things that previously weren't portable are now potentially portable. Not everything will be, but there'll be a lot more portability because of this project from older deployments. And then Gateway Cuddle, which is kind of like kubectl for Gateway. It's actually a plugin, or rather, I think we're on the way to making it a plugin for kubectl. But there's some like visibility things and some other things that Gateway does things a little bit differently. Gateway API does things a little bit differently than some other Kubernetes APIs, including the policy bit. So Gateway Cuddle is kind of one of our many ways in which we're trying to help improve the operations and stuff of gateways by like giving tools for like looking at what policies are affecting my routes, that kind of thing. Yeah. So that's it. And we'll talk a little bit more about this last year. Basically we started to refer to it as the road to GA. We'll do a little bit of a retrospective and talk about like, especially in this last year, what things went well, what things didn't go well, and then what we decided to do about them. So some of the things that really paid off, and we talked a little bit about these, but like we did end up with a pretty decent iteration process, pretty quick, using CRDs instead of being in tree and having a GEP process instead of using the KEP process. I believe if we hadn't done these, we probably wouldn't have been able to release as GA in 4 years. It would have taken more time. These things made us very flexible and able to kind of, move. And then our release channels really helped with this in the last year or so, where we're like, okay, we're starting to get into like the place where we feel like we need to slow down and make this thing stable, but we really don't want to stop adding more experimental features and trying more things. Release channels made that possible. And then I can't emphasize the importance of it enough, but conformance really, really it keeps paying off. So we have conformance profiles, which are like things you can subscribe to and say like, my implementation does HTTP or mesh, and then it'll run the test suite for you with that profile and run all the tests relevant to that profile. We have conformance levels, which just map to the support levels. Like your implementation needs to implement everything or run the tests for everything in core, but optionally can add extended features. Implementation specific isn't really relevant here. If something is implementation specific, if it's testable, it's going to be an extended most likely, but there are like references to it, and it's a gray area that we're thinking about for the future. And then conformance reports. This is huge. So like ingress, the ingress resource in Kubernetes, had a conformance testing. It had conformance testing, but it didn't work. It didn't happen really. It never really came to full fruition, and a lot of that is because of the portability issues and getting people to the table when they're all doing wildly different things. Now we have, most of the people at the table talking about all the features that they're doing and putting them in conformance tests if it's something that at least one other implementation can do. And so on top of that, conformance reports is like, as a maintainer, one of the best things ever, because we used to have to know what people are actually implementing in their implementations, like what features they're actually trying to implement. It was kind of like query Slack, like, hey, is anybody using this? And that was pretty lossy, if you can imagine. So conformance reports is literally, we have a reporting system and we incentivize implementations with, like, we badge them and kind of give them accolades for reporting to run the test suite, which now produces a report and send that back to us. And that's available for us as maintainers to keep track of who's implementing what, but it's also available for users to go look at that, to say like, well, I need something that implements this feature. So you can go look at the conformance reports and say, okay, this meets all of my needs. This implementation does. So that all paid off. That was stuff that paid off. And ultimately, we delivered on time. We did it. This is a picture of us at KubeCon Chicago at one of our, we did one of our Gateway API office hours, which those went really well. We did them every day, and actually most of the time they went over an hour. And we did it. V1 is here. More than half a dozen implementations are now reporting conformance results. So that is the reports I was just talking about. So like, we're getting good feedback on what people are actually implementing, and it's growing over time. But not everything went well. It was a learning experience. We'll talk a little bit more about what didn't go well. So biggest challenge, we'll talk about some of the challenges, but the biggest ultimate challenge, the biggest takeaway that I have from especially the last year was not really a technological one. There was more interest than we'd ever anticipated in this project, an absolute overload of features, which you could say is a good problem to have, and it is, but it's also a problem that needs to be solved. We needed to do better at managing time and priority, ensuring fairness. We, as maintainers, um, I think everybody thinks of maintainers a little bit differently, but as maintainer of Gateway API, a project this big, the real thing that you're doing is being kind of like a court in service of everyone in the community. That we are in service of others. We have to protect their equity in the project. We have to ensure fairness. We have to be inclusive. We have to make sure that while we're doing all this, we have, we're making sure people can come in and get, their share in the project. They can get their voices heard. And this is incredibly hard when you have 9 million things coming in the pipeline at all times to manage these things and make sure that you're doing service to everyone. So we had a project management problem, which was our biggest challenge, and in a project run entirely by volunteer engineers. So volunteer engineers are, trying to figure out this kind of massive project management problem in the last year, as we're also trying to figure out all these technical problems. It was very challenging. So many features. I mean, these are features I think I listed here that aren't even here yet. And they've been in the pipeline most of the year and are on their way for future releases. Session persistence, per gateway infrastructure, gateway class supported features, meta resources and policy attachment. We talked about that. That's kind of a long-term ongoing thing with a lot of twists and turns. destination port matching. gRPC route actually is probably one of the ones that'll come sooner rather than later, I think, but it's still kind of in the pipeline being worked on. Gateway routability. So that's things like being able to say whether or not a gateway is accessible in cluster or outside of cluster. Turns out Kubernetes itself isn't great at like in cluster and outside of cluster being real things. So like that you can actually queue into. So we have to solve that, and it's going to be an interesting one. Mesh conformance. We got to work on the conformance test to get mesh to the point where it can graduate from experimental to standard. Conformance profiles and reports. That's actually really close, but it's still kind of underway. We're thinking we might have that one into standard and kind of more stable, basically, for people to keep implementing on in time for KubeCon Paris. We'll see. And then HTTP route timeouts, which is kind of a big one people want, has actually been harder than you'd think. So this is just some of the features. It's like not exhaustive. There's like 17 or something like features just in the pipeline right now. 4 would be enough to completely like load down a project. Like 4 would be enough to take up a year. We've got like 20. So it's been interesting. So things that could have gone better based on all that, project management overall. I think this isn't really just a gateway API problem. I've learned more and more, especially in my work as just a SIG chair, like this is just an open source problem. We're engineers. We didn't have a dedicated project manager. I certainly took up that role in some of the final months before the release to make sure, we released, but like there's no dedicated project manager. And in fact, it's hard to get project managers to come and work on open source in that capacity. We don't see any at the moment. Kind of a big problem for larger open source projects in particular. Lots of GEPs did slow down to a crawl near the end, and this was like, we really wanted to make sure that like everybody felt heard and taken care of, but there was a point where we're like so bogged down and trying to fix our project management problem at the same time that like we literally had to do Zooms and like talk to people and be like, hey, it probably looks like we're not like responsive, and it's just because we're responding to the world, right? Like everything right now. And most they were all like, we got to a point where everybody kind of understood, and we got to GA, and now we're trying to get on a better path where things don't feel so slow. But we bottlenecked really good in the last few months, certainly. And then some experimental things. Experimental, never in being intended to make it to production, made it to production because they sat around so long. And actually, it was kind of specifically policy. That was in experimental for 2 years. Yeah. So like people were implementing it and they was like, well, it's been around for 2 years. That's GA. And so they have policies based on our experimental reference kind of for them that are in production. So that's a big problem. We were unable to work on layer 4. So actually, this is one of my favorite. This is kind of my pet project. Was actually I wanted to get layer 4 ready in time for GA and to like at least like a beta-like state. But we just weren't able to do that, and we don't have any champions coming out of the community to drive that. So that kind of just hit the that just kind of got didn't get the highest priority in this ramp up to V1. It's getting more more attention now, and will be something you'll see in future releases. So action items, all these things that didn't go well, and this wasn't an exhaustive list of things like that we did in our retrospective either. But one thing we did during the time and during this year, and the reason why we even have it, why we called it the Road to GA, is we literally had a project board. It's finished now, but this is one of the ways in which we got ourselves organized and like actually looking at like triaging things as they come in properly, giving them priority. We started doing regular meetings instead of the community meeting, like regular meetings just for this purpose, like just to organize the project, because that's how active the project is. And this was pretty successful in giving us a way to like keep track of everything, make sure we got things in the right priority, figured out what the milestones actually look like, what needs to be released, and push things from left to right and ship it in time for Chicago. And we just made it. Like we literally released right before Chicago. We changed our entire process and philosophy during this time too. Like the get process, we wanted get to be really lightweight at first, and it still is pretty lightweight, but we had to add some things basically to kind of make the pipeline to organize work better. We had to come up with some early consensus steps. Like one of the things that happened a lot was we would have people come to us and say they wanted a feature and tell us exactly how they wanted that feature to happen. And then that would go into a PR, and that PR would go into PR hell. It would just for a long period of time. It just nobody could make any progress because it would be too contentious, or people would have like non-prescriptive comments in response to it, like things that you didn't know how to act on. So you had to synchronously sync up with them to try, just take forever. So to combat that, we added this into our documentation that there's a what and why phase, basically a building consensus phase about what you want to do, clearly defined, why you want to do it, which is something that you need to find consensus on with other people in the community, with know how. Don't tell us how. We don't want to know how it's done. We want to see if it's something that people understand as a problem and why they want to solve it. That has been pretty successful. We've still had some, PRs that haven't gone well and stuff like that, but we're slowly moving towards this kind of being the way we do things for the future. And in general, people seem to like it because it gets us more iterative. We'll have like, we'll actually start there, and they don't have to be mad about like what the implementation looks like. They agree with the principle first. And as a part of that, so once you do get to the how, that can still be contentious. And we added a prototyping extension to our get process, which we've only used once so far, but it's been to pretty good effect. And that's basically like some rules that allow you to start doing an implementation, but behind like a curtain, like isolated. So like in the case that we did it last, literally behind a Go build tag called experimental. So it's not part of the regular build, but the code can be there and you can iterate on it. And that gave us the opportunity to, as part of a GEP, you don't just see what somebody wants the implementation to look like and try to figure that out in your head, but like have an active prototype that you can go use and see if it works for your implementation. And it's a lesser thing than the what and why, but it's definitely been a helpful change to our process. And then in general, we extended the GEP graduation criteria. The graduation criteria wasn't solid or firm enough, and that's why like policy kind of made it into GA, even though it's experimental. Now we have like explicit rules and including a probationary period. The default for an experimental GEP is now that it will be declined at the end of a probation period, which has a default, and you can argue for a different one based on your project. It will be declined by default unless it actually meets its graduation criteria, which it needs now in order to even make it to experimental. Experimental isn't just can other implementations implement it and doesn't have conformance tests. We need an explicit graduation criteria that's agreed upon by all the stakeholders, and then you have to get that done within a time period, or the default will be to shelf it. Which doesn't mean it's dead forever, but it'll, the idea being that people won't just take these things into production and say, well, they're in production now, because we'll be like, well, the default was not to move forward. It was to not move forward. We did a lot more feature and maintainer meetings. I think I kind of talked about that, but they basically just tons more meetings to keep organized, do the project management stuff. And ultimately, when it came down to like maintainership, it was the three of us for a long time, or rather, it was just a few of us. We added the contributor ladder in the last couple of years, and this has been immensely helpful. We were 3 maintainers, and now we are 3 maintainers, and we have like 12, I think, like something like a dozen official roles within the project. And we need that many people to manage a project this big. So they all help out with different facilities. This has been super helpful at not only just like getting us more help and kind of keeping the project better organized, but it also has been good to like be able to recognize people for their work and stuff like that. And then this one's subtle, but GitHub discussions has been really great. I think some projects do well with a forum, right? Sometimes you have to have like forum software running someone else. Something has to be like, you have to log into it. You have to make a different sign in just for the forum. GitHub discussions has been really good for us because it's like you already have a GitHub account if you're here. So the forum's just here in the GitHub repository. I think we have one of the more active discussion boards of all the projects within Kubernetes, and we just get a lot from it. So much so that our get process actually starts with a discussion. And so that's been going pretty well. So now that we're absolutely overwhelmed with how it all got here and like some of the trials along the way, we'll talk about what's next. We did it. We got here. It was a lot of work from lots of people. Thank you to everyone. What's next for Gateway API? Well, any of you who have been, for those of us who have been doing software development for a long time, we know that GA is really just the beginning. And that is definitely our mentality with Gateway API. We have stabilized a few APIs, that we know we want to kind of maintain forward with backwards compatibility. But there's a lot more coming in the pipeline, and I'll talk about some of those. Probably the most hotly requested feature is HTTPRoute timeouts. You can specify new kinds of timeouts at HTTPRoute rule level. Here's an example of it here. So there's a rules timeouts. This also had to come along with its own duration format, which we had to come up with and like make sure every implementation could kind of agree with that duration format. It was ultimately based on Golang's. We decided to go with Golang's time format. It's been hard to do this one, but as the most hotly requested feature, it's kind of been a top priority. So that's GEP 1742. If you're interested, I'm not going to go into each of these in great detail. I'm going to tell you a little bit about them. So I'll have links to the GEPs, the enhancement proposals, that right there, where you can go like dig into these deeper if this is one you care a lot about. We have backend TLS policy, which I alluded to earlier. This is our first official policy as opposed to it just being kind of like guidelines. And this allows you to do TLS validation for backends. You can do system CA certs, or you can provide an object reference for in-cluster CA certs. You can do host name serves as the SNI to connect to a backend, and the requirement that the backend serves a cert with matching subject name. This one is, I think it's pretty likely going to move into, it's an experimental now. Actually, all of these are experimental unless otherwise said. It should be on its way to standard, I would expect sometime within 2024. And it's also a very hotly requested feature. Gateway infrastructure labels. This one was kind of interesting. It's kind of like a blocking requirement for a couple of implementations, but basically gateways, the resource, tend to be composed down at like when the operator picks up a gateway, it tends to compose down to an actual Kubernetes service being involved, usually for the IPAN to get like a load balancer IP for the gateway. We do that for our Kong gateway operator, for instance. And certain users on certain cloud providers and stuff like that need kind of it's supposed to be an implementation detail, but they absolutely need a way to influence that service to put annotations for like AWS or what have you on that service so that it operates a certain way. So we did add something for this. This is an experimental right now. We're trying it out where you can basically just propagate annotations down to these services if they exist. It's kind of a weird one, but the need is very great. So we're trying it out and seeing what we get. Backend protocol defines the interaction with app protocol and service port. So this is relevant for HTTP2 WebSocket support. We added a few things upstream for like H2C, WS, WebSockets over clear text and WebSockets over TLS. If you're interested in these kinds of things, GEP 1911, QR code right there. Gateway cuddle, we talked about this one. It's actually within the main repository as like a CLI, and we put it in there so that it keeps in track with like all the other code. This came up during the policy attachment talk specifically. The first use case for it was to be able to describe policy. But it's a CLI that you can use to kind of like observe and look at what's going on in your cluster relevant to gateways. It currently computes the policy attachment and extensions. So like if you have your own custom policies in your implementation, with kubectl, you'd go look at like an HTTP route. You'd say get HTTP route, and you wouldn't know that if there was a policy attached to it. This is why policy attachment has stayed in experimental so long. We haven't really been able to solve one of the visibility problems of like how do users even know their routes are being affected by a policy. Gateway cuddle helps with that by like giving you that computed result. It also just does things like do describe for gateway resources. You can't today, you can't do like good describes for CRD APIs. So this allows that. And then it surfaces potential problems. We're looking at like, it's a work in progress, but we're looking at like, how can this help you see problems before they become real problems with your routes and your gateway and stuff like that. So that's on the horizon as a potential thing as well. Conformance profiles, actually Mattia Lavaca, who works with me at Kong, and I are kind of have been driving this one. And this is the test suite, the profiles you subscribe to, the reporting, all of that. So it's really close to being ready. I think the only things we have left really are documentation, which there's an issue for. There's modes, there's a modes thing. So like Istio and some other projects can be deployed in different ways that are actually have significantly different capabilities. So it doesn't make sense to like run the conformance tests for one of those modes, but not the other, and say that, so we're adding modes to basically allow you to run your implementation in those different modes with different test results and report that. And then there's a lot of like cleanup items and stuff like that. We're also actively looking for somebody to help with the reporting part. So the reporting part works and it's nice for us maintainers, but it's literally like YAML reports at the moment, which is not great it's not great user experience. So we are looking for UI people. If you are a UI person who wants to help us with our website and like figure out a good way to make these reports look really good and be more useful to like end users, please take a look at issue 2550. We would love to have help with that. We're like, a lot of us are like back end, lower level networking devs and stuff like that. So you won't get a great looking website out of me. Graduate, and then ultimately we want to graduate it to standard to make the library stable. That's GEP 1709 if you're interested. QR code right there. And I think this is the last one, but this one's actually provisional. The rest of them have been experimental. Session persistence, another just super high, like everybody wants session persistence. We have the starts of a GEP for this, 1619. It's actually been around for a while, but it's been hard to move it into experimental and like build consensus on it. We're hoping that we'll be able to do that sooner rather than later. Its intention is to define both session persistence and session affinity, so like provide a definition of these, but only specifically implement session persistence in Gateway API. If you're interested in that one, GEP 1619. Yeah, and then it's like I said, it's just kind of endless. There's features come in every day. We have 9 incoming features. Some we talked about: meta resource, policy attachment, destination port matching. Gamma is an ongoing thing, and it's a bigger one. Gateway routability, multi-cluster. Multi-cluster has ebbed and flowed over the years. There's always been like moments of really strong interest in that, and there are some implementations doing like multi-cluster gateway stuff. So it's interesting. In-cluster gateways, which is just literally gateways that aren't accessible from the outside. Supported features is kind of a cool one. That one's we're working on. We're like, the features right now that an implementation supports are kind of only visible in the reports. We actually want to make that something that appears in the status on a gateway class. So from your cluster, you can ask the gateway class, what features does this class support when I create a gateway and route? And that's what we're working on there. Session persistence, we talked about. Per gateway infrastructure is about configuring gateways. All the other routes, which we are, there's lots to say about these, but it would take we could do entire talks on each of them. gRPC route, TCPRoute, UDPRoute, TLS route, reference grant, which is, again, is, potentially going upstream. And then new ideas on the horizon, like things coming in all the time. Egress is a thing that's come up fairly recently. Using gateway as a router, like we talked about a little bit earlier too. Like there's interest in actually, instead of just proxying ingress into pods, having pods in the routing tables literally route egress traffic back out through a gateway. Generally, layer 3 functionality has come up a lot, and that kind of goes a little outside of the scope of what Gateway API has tried to be in the past, but we're looking into it. Cluster IP gateways, I think I already talked about that one. HTTPRoute plugins, that's one at Kong. We're kind of really interested in having like a portable way to do plugins, something like WASM, stuff like that, so that people can kind of define that one way and then bring it to and from any particular implementation. Gateway DNS policy, it just goes on and on. The list goes on and on. If you're interested to kind of just look at it all, the GEP overview is in that QR code, and just kind of you can see everything that's kind of in the pipeline at the moment. And that's not actually everything in the pipeline, because some things are brand new and in our discussions board. So again, now that you're thoroughly overwhelmed, how do you get started on all this? Well, if you want to get started like using Gateway API, you try it out with any of we have 3 implementations of Gateway API for 3 of our different products. We have our traditional Kubernetes ingress controller, Kick, has Gateway API support. Kong Mesh and Kuma has 2 levels of Gateway API support. It supports ingress, like the standard kind of Gateway API support. And then it also does have the preview level service mesh using HTTPRoute, not just for the north-south, but also for the east and west traffic. And then the recently released Kong Gateway Operator, which is meant to be kind of focused on gateway, for using Gateway API as kind of the center of managing the configuration and lifecycle of gateways. So you can try any of these. These QR codes will take you, I think I made them specifically take you to the gateway API sections of the documentation. And then in general, if you're more interested in like just getting involved with the community, here's our website. Here's our page on how to get involved. We have regular meetings all the time. We have like 2 a week basically. Gamma, and then the regular meeting is usually on Mondays. You go to that link and it'll tell you all about the meetings and stuff like that. We're very active, and you can reach us on SIG Network Gateway API channel, on Kubernetes Slack, and then obviously our repository, which you can create issues, you can join in the discussions on GitHub. That's Kubernetes SIG's Gateway API. Yeah, so we'd love to have people get involved. We're trying to get organized around like good first issues. We've had a few of those lately, and like make sure there's like smaller ways you can get involved if you want to start in like some tinier things. Documentation is always a big one. The website, anybody who wants to come in and make the website look nice, we'd love to have that. But there's plenty of opportunity within the project. And now we can open it for questions. How did I do on time?
Thank you so much, Shane. That was awesome. Very, very informative. We have about 7 minutes left. There are 3 questions in the Q&A. Can you see them?
I'm switching to the Q&A.
All right.
What are the major differences with Kik, and what could be the benefits of moving to Gateway API? Will Kik fade out as Gateway API matures? I can answer both of them. So the main benefits are those features that I in retrospect. So I've had other talks where we compare the features between like ingress and HTTPRoute. That is the main benefit from a Kik perspective, is like there are many more features and portable features. So you get more features and they're more portable. That's why you would do that in Kik. With a KGO, we also add the configuration and lifecycle management using Gateway. So it's kind of a step up if you want to have like automation for gateways as well. As far as will Kik fade out? No. As Gateway API matures, no, absolutely not. It doesn't have, if you're thinking like Gateway API outmodes Kik, no. If anything, other APIs that we used to use will fade out in favor of Gateway API, but the Kik will stick around forever. In fact, the Kik is one of the core components in the new calling gateway operator. So it's definitely not going to fade out. Are conformance reports public right now? Yes, they are in YAML. I am sorry. I don't do UI, but they're there, and you can go look at what people are reporting today. There's reports for V1. And again, we are looking for somebody to help us make those look nice, have a better like UI presentation of them, but they're there, the data's there, and we're using it. So that's, oh, you probably wanna know where it is. It's should be in the repository under conformance directory/reports directory. There should be like some navigation there, and you should be able to see where the reports are for the different implementations, including Kongs, including Istio. Like there's quite a few reporting at this point. And then another question, the Gateway API meeting times make it difficult to participate for, I think, most of Asia. It's true. We're actually kind of aware of this, especially India. And if similar for Gamma, plans to change it. So this has been really hard. So you can imagine with as many people want to participate in Gateway API, but we did recently make the change to every beginning of the month, do our talk on Tuesday. That used to be on Mondays. They're now on Tuesday instead, some 8 hours earlier. Now, I think that's still not a great time for India. I think the time ends up being something like 5 or 6, 7 p.m. It's in the afternoon, but it's way better than the previous ones. So if you want to give those a try, and then keep telling us this, because we need to keep working on this, like how we can make sure that we're including more time zones. This has been a hard one to tackle. So we want you to be noisy about that, and we'll keep trying to make that better. And if we need to make just a separate meeting just for like India and stuff like that, we'll do that. It's just a matter of like, you got to poke us, keep pushing us to do that, and we'll do that. I think that's it for open questions. Please do feel free. I'm having a little coffee. Please do feel free to drop some more in there.
All right, we have a couple minutes left. Any last questions? Drop them. Yep, one more.
All right, in the end, whether the configuration is parsed by the Kik or KGO, queue features need to be supported by the proxy. Are you planning to move features from the mesh to the proxy? No, I don't think that we are planning to do anything like that. And if you have some specific, you're saying parsed by the Kik or the KGO. So just to be clear, The kick is a component of the KGO, so it is the kick regardless. Queue features need to be supported by the proxy. Are you planning to move features from the mesh to the proxy? It says, for example, weighted traffic like virtual service that can now be done directly in the gateway. Okay. So like, yeah, that is in the proxy, the weighted traffic splitting. I think that was always available, but it was much harder before Gateway API. Like doing it was a little weird. So hopefully that answers your question. But if there's more to your question, I get the feeling that there might be, please do drop an issue or a discussion on the kick repo. We'd love to hear like what exactly you need. That kind of feedback, especially from the perspective of like the engineers working on the kick, is wonderful for us because we get quite a bit of gateway API feedback right now, but we usually get it through channels like other than like the issues and stuff like that, but the issues help us to organize it around like actual things that we deliver on our roadmap. So please do put in your feature request or any other relevant questions you have there. I don't see any other questions. Yes, thank you. We appreciate it. Please, if you can take the time to make an issue, we love that. It helps us a lot. Everybody sees it, like our product manager sees it, that kind of thing. Thank you.
Any last questions? One more minute. Let's see.
Cool.
All right.
Thank you all for coming. We really
Shane,
appreciate it.
thank you so much for the presentation. Thanks everyone for joining. We love to have you on our next webinar, which is actually happening next week, and that will be the last webinar we have for this year, community webinar. So I'm going to put the link in the chat so everyone can see it. It will be on Kong Gateway 3.5 and WASM support. So interesting topic. Join us. Cool. Thank you, Shane. Thanks everyone for joining, and we'll see you next time. Happy holidays.
Thank you, everybody.
Bye.
Happy holidays.